Welcome to the Robot Philosophy Podcast, where we keep you up to date on the latest news, reviews, and anything new in the robot world. Hi guys, Philip English here, RoboPhil. Just another interview for you, just to quickly obviously learn some more about the new or some more robot companies that are out and about. So today we've got Jack Corns from HausBots. And we're going to give you a quick overview to see how they work, really. So welcome, Jack.
Hi, how you doing?
Thank you. Fine. Thanks for your time today. So really, I mean, just to start with, it's probably worth getting like an intro sort of for yourself and just a little sort of profile on the company, if that's okay.
Yeah, sure, no problem. So, hi, yeah, I'm Jack. I am the CEO, one of the founders at HausBots. In a nutshell, then HausBots build robots to protect and maintain buildings and infrastructure. We started the business when my co-founder was asked by his parents to paint his house. He was up on a ladder, painting his parents' house, thinking to himself, blimey, it's the 21st century. I've got an engineering degree. There's got to be a better way of doing this. So he made our first ever robot as nothing more than a bit of fun in his garage to help him paint his parents' house. We've known each other since we were about 12 years old. So we were having a catch up one day and he was telling me about this idea that he'd come up with, and a bit of a eureka moment happened for me. At that time, I was working in big tech, selling mainly software-based automation. And the eureka moment was seeing how the task that his robot solved, which was effectively making work at height safer, wasn't really being matched in the market. There wasn't really a product out there. And I knew how much money was being spent on automation at large. So we decided it would be a perfect opportunity to get together. I brought the parts of the puzzle that he was missing, you know, sales, commercial, that sort of stuff, and started the business about 3 years ago. Fast forward to today, and we've morphed from a robot to help a kid paint his house to a robot that can make all types of work at height significantly safer and significantly more cost effective. So what we've actually got is a really clever climbing robot that can climb any surface you can imagine. And then we can integrate payloads up to 6 kilograms. So we do all sorts of projects, from concrete inspection through to painting, through to metal inspection, you name it. We can work out a way of getting our climbing platform to do it.
Right, it's a fantastic overview. Thanks, Jack. You know, that gives us a good spec on the company. So I suppose the first question that you must always get, so you say any material there. So what stops it like slipping on like very wet and slippy material? Like, is it something to do with the way that the device, I suppose it must suck onto the building? Is that how it works?
Yep. So we use a particular type of aerodynamics that's found in Formula One called the ground effect. The way that it works in Formula One is that the undercar side of the car is designed in such a way to enhance its airflow under the vehicle and create a big low pressure. So we use that same principle, but use a fan. So this fan is moving the air to create a low pressure region underneath our chassis. The reason that that's kind of clever, different, and what our patent is based on is that it means that you can create large amounts of suction force without sealing against your surface. So most of our competitors will use, let's say, a vacuum cup, suction cup, something like that. But our robot doesn't need to seal. So we've got almost a 2-inch gap underneath the robot. So then it can generate these suction forces against pretty much any surface. We use that in combination with extremely high friction tires to mean that, you know, roughness of surface or obstacles or wet surfaces or smooth surfaces doesn't really matter or affect the robot.
Right. And then for the actual painting of the walls, then I'm assuming that there's like an extra line that comes off the robot with whatever paint that the customer wants. Is that how it works?
Yeah. So the robot can be integrated with any attachment you can imagine. It's got all sorts of integration ports, just like you'd find on your laptop, you know, USBs and communication and all sorts of things. So you basically plug the robot into the attachment that you want to use, which if we're talking about painting is just a paint gun. Attach the paint gun to the mounting point on the robot, plug them in for communication, and then that paint gun is supplied with a separate feed.
Right. Could you put a camera on there for building inspection? Because I was reading in the news lately that there's a lot of buildings around London that have to potentially need to be like inspected more. So could that be like another feature that the robot could do for something?
Yeah, it's already a feature that we use extensively, actually. So we've got a 4K pan, tilt, and zoom camera that can sit on the front of the robot. And again, because it's easily integratable with all sorts of different things, we could even change that camera, upgrade it, use thermal cameras, whatever you fancy. But yeah, we already use the camera quite extensively, especially in areas where it's extremely difficult to get a drone permit, or you can't fly a drone, which is most cities, around most buildings, around most road networks. Then drones can't be used. So our camera on our robot fills a nice gap there.
Right, and you just answered my other question, actually. Yeah, because I was going to question about sort of drones, but with the understanding from the health and safety side of drones, then that makes sense.
Yeah, it's a licensing thing, it's a health and safety thing, it's a permit thing. More fundamentally than that, our robot was specifically designed for tasks where you require contact with the surface. You know, drones today are pretty much only good for cameras, for photos. And yes, you can use different types of cameras, thermal cameras and whatever, but that's about as far as you can get with a drone. Our robot lends itself perfectly to tasks where you need to be touching the surface. So a radar survey, an ultrasonic survey, camera of something extremely close, you know, painting, fixing a particular thing, those sorts of tasks, which is where the functionality is kind of enhanced versus a drone.
And that's the advantage, really, because you're doing a physical job as well. You know, obviously you can do the vision inspecting, but you're actually doing a job, you know, so it's either it's painting, that's or right. You know, or something like that, and actually like repairing the building. So yeah, I can definitely see the advantages. That's right. Like, what's the highest it can go, or is it can go as high as you like, as long as you've got the power cord that's long enough? Is that there?
Yeah, well, there's two versions actually. We have a 30-meter tethered version, so customers will often use that if they want to run continuously. So you can power it through the tether and have unlimited power up to 30 meters. Or you've got a battery version. So the battery version is unlimited. Obviously, as soon as you can carry the battery, you can carry the battery up to any height. But it's limited by time. So you've got about 25 minutes of runtime, which is somewhere on par with a drone as well. So it depends on what the customer wants to do.
Right. Okay. And I suppose, like, what's been your most sort of trickiest building you've done so far? What's been the tallest one you guys have done?
Oh gosh. We did the QE2 bridge in Dartford.
Okay.
The robot was climbing up one of the support piers. We undertook a visual survey and a radar survey. That bridge is huge and was an extremely exciting asset structure for us to work on.
Right. Yeah, that's amazing. Well, I could definitely see, you know, the future potential, because obviously, you know, once people want their building painted or for inspection, I mean, what's the next step for you guys? So you got the two different options at the moment. Is it really just to expand the options, expand the lines?
Yeah, we're constantly improving on the fundamental physics of the thing. So you can always create more suction, you can always overcome a slightly larger obstacle, you know, all these sorts of things. So that'll just happen naturally. But I think the biggest piece of work that we're doing is just constantly upgrading the portfolio of items that we can integrate with, because ultimately the climbing robot itself, whilst is our bread and butter and is our special thing, the climbing robot itself is pretty useless. You can't really do anything with just a climbing robot. So it's all the attachments that is what it actually makes it do useful, productive work. So yeah, we've got all sorts of projects on at the moment to just make that base robot integrate with as many different attachments as possible. And really, the nicest analogy to draw it to is a tractor. You know, a tractor is pretty useless if all it can do is just drive around fields.
Yeah.
What you need is your tractor to be able to bolt onto your plow, your harvester, your tree cutting machine, you know, all of these different things that your tractor then powers. And that's kind of how we're seeing our robot.
Yeah, no, I like their like analogy. That's really good. So the max payload currently is 6 kilograms.
That's right.
Because what I was thinking is that, well, I suppose the next step would be to have some sort of cobot arm on the back of it with a tool of some degree. If you wanted more weight, well, I'm guessing it would just be a bigger robot. You'd have to just size everything up to fit something heavier. I mean, I know the cobot market, the robots are getting lighter all the time, but I don't think we've got, unless it's a university one, a 6 kilogram one yet. So if you wanted more payload, could you do it? Would it just be size, or could you add more technology in there so you can up the weight without having to double the size?
Yeah, there's size is one way of doing it. It's kind of cheating, but that is one way of doing it. What we mainly focus on for payload improvements is aerodynamic designs. So you know, we're doing pretty much Formula One levels of aerodynamic design, and in the same way that a Formula One car every year gets about a second quicker because they found a new wing which can generate downforce in this particular way, it's the same sort of iterative circle that we go through. That being said, and where the first part of this question came from, we've recently created a partnership with a manufacturer of basically mini cobot arms, and we've got an arm that weighs 3 kilograms, is 6 degrees of freedom, and attaches to the front of our robot. And it only has a small payload, obviously, but we've already started to do much more precision manipulation tasks through that 3 kilogram arm.
Wow, that's really impressive for 3 kilograms. Yeah, I don't think I've ever seen one that sort of small before. I suppose it's almost going into sort of like, they're talking about nano technology and nano that sort of standard. And I guess, you know, the smaller robots that we can build to do the work, the more you're going down that road. So
yeah, that's right.
Yeah, I mean, tools. So we've seen from companies like UR and Robotique and OnROM, they're producing a lot of end effector tools right at the moment. That's definitely the trend that we've seen. So you've had a series of years where they bought the arm, they weren't too sure what to do with it. It's got a gripper, it's got a pick and place function, but now we've seen they've got sanders on the ends, they've got drills, they've got all sorts of tools. So you can imagine, you know, the most dangerous job that you can get is being on the outside of the building trying to screw something in. So
that's right. Yeah.
You definitely see the advantage. So you guys, so you're based in the UK?
Yep.
Right?
Yeah. Yep. Birmingham. Yeah.
Oh, okay, over in Birmingham. And yeah, I mean, I suppose from our viewers' point of view, like to get in contact with you, obviously, I'll put in the HausBots website below and put some details. And yeah, I mean, I'll have a think on this side as well to see if there's any opportunities or customers. I mean, again, as part of the TLA like robotics group, we may have you on there as well, because that's a European base as well. I mean, have you done any installs in Europe or abroad? Or
yeah, we pretty recently came back from a chemical tank inspection in the Netherlands, and there's a couple of different customers that we're talking to now that are based in that region as well.
Right, fantastic. Expanding out.
Yeah. So yeah, we're kind of giving demos and tests and pilot projects as we speak. So yeah, happy to engage for a demo with anyone.
Yeah, and then the 3 kilogram arm, is that something you might see on the website in 6 months' time or something like that, or is it?
Yeah, possibly. Yeah. Yeah, you can. It's a manufacturer called Elephant Robotics. And,
okay.
yeah, they basically specialize in mini arms. really quite impressive stuff.
Oh, are they UK based as well, or
They're in China actually.
they're China? Yeah. Okay, that's interesting. Yeah, I'll have to look into those guys as well. Okay, no, that's great, Jack. I mean, thanks for the overview. I think that's given the audience a clear understanding of what you guys do. And yeah, I mean, we'll keep an eye on you. I mean, we may do another interview in a year's time or something like that, see what
Sure.
extras that you have on then. So that'd be great.
Yeah. Good stuff. Thanks a lot then.
Cool. Thanks for your time, Jack. It's very much appreciated. Take care. Bye-bye.